Hello and welcome to the first video of the school year. Today we're going to be talking about variables and expressions. Okay, this is stuff that you already know. You've already dealt with these things, so it's going to be kind of a review for you, but it's a good start to getting into algebra. So first thing, variable, right? A variable is just something that represents a number in math, right? And it can vary. So for example, one of the common variables that we use is the letter x, right? X could be any number. And that's why it's called a variable, because it could vary, right? X could stand for 4, X could stand for 25, X could stand for a negative number, all kinds of things, right? And we could use any letter. N is another popular one, Y, all kinds of letters known as variables. They could also be used in short expressions. For the example, 3y. So it's saying 3 times y. And y is just some number. It could be 3 times 1, 3 times 2, 3 times 3. We don't know. So we say 3 times y, or 3 times some variable, well, whatever letter you use. I'm going to jump ahead of myself. We have algebraic expressions, right? What's an expression consisting of one or more numbers and variables along with one or more operations. Okay, so I need an operation in there. That's the biggest difference. So if I would take x plus 3y. That would be an expression, right? Because I have numbers and variables, right? And an operation, right? I got an operation right there. I got a plus sign, okay? So that's an expression. The only difference between an expression and an equation is that an equation has an equal sign. That's the only difference, okay? So an equation, I can have the exact same expression here, and if I put it equal to something, now it's an equation. X plus 3y equals 12n. Okay? That's the only difference. So expression, no equal sign. Equation, there's an equal sign. And then our last term down here is term, actually. Well, a term in math, I always think of it as anything being added. And I'm going to add another part that someone said minus 14. Okay. So if I look at this expression right here, let's take a look at my terms. Well, here's one of my terms. X would be a term, right? 3y would be a term because that's being added. And my last term would be negative 14. Negative 14 would also be a term, because if I think about it, I'm really adding the opposite. I'm really adding a negative 14. So that's why we say negative 14 is a term. So basically anything that's being added would be your terms. Whenever we deal with multiplication, we got a couple terms. Everybody knows what the product is, right? The product is the answer when you multiply. Sometimes we tend to forget, what are the numbers called that we multiply by? Well, 4 and 9, the numbers that we multiply to get to 36, we call those the factors. Because 4 and 9 would be factors of 36, right? Because 4 times 9 gives us 36. So just a couple more terms, quick refresher. Another one that you dealt with last year, we got into powers, right? Power is taking basically a number or a variable and raising it to a power. So let's just look at one with some numbers here. If I took 4 to the third power, okay, 4 to the third power. That means I'm taking 4 times itself 3 times. So this really means this is the exact same thing as 4 times 4 times 4, which in that case is 64, right? It's not 4 times 3, it's 4 times itself 3 times. And we have some terms for this. So this whole thing is called a power. The bottom part of it, okay, so the 4 and this x, we call the base, and what we raise it to, in this case we're raising it to the n power, we call that the exponent. The exponent. And I think these are all terms that you've covered before, but just a quick refresher on our terminology. Okay, because we're going to get some expressions here, like you can see right here, and we're going to write out almost like a sentence for it, a verbal expression instead. So basically, like my first one, for number 1, I have 8x squared, okay? Well, how do I read that mathematically? What operations are going on in there? Okay? It looks like I'm taking 8, and what am I doing with that x squared? What's going on? What operation is in between here? Well, it's really multiplication, isn't it? It's 8 times x squared. I could also read that as 8 times x to the second power. Right? There's numerous ways to read exponents. But basically, I want to write a verbal expression for this. Okay? I don't have to write the word 8 out. I can just use a number. I can just say 8. But I'm going to say 8. What's my operation? We're timesing 8 times, well, two ways I can say this, right? X squared, x to the second power, however you want to do it. So I'm going to say 8 times x squared. I like reading it that way. And I got to write that out. 8 times x squared. So I'm kind of writing a sentence. I'm writing a verbal expression for my numbers and variables that are written. Yeah? Let's look at number 2 here. Y to the 5th minus 16y. Okay, the way I read it is almost exactly the way I could write it. But I would have to say y to the 5th. That sounds good. Y to the 5th power, really. I should use the word power, right? Y to the 5th power. Minus, I'm okay with minus there. I can't just say 16y. What operation is that? It's 16 times y, isn't it? Same thing with number 3. I could say the sum of each of these terms. Okay, but most people don't do that. Usually we just say, plus for the plus sign. So I'm going to start it off. I'm going to say, well, 1/2 a. That's really 1/2 times a plus, well, I'm not taking 6/7 times b. If we notice, the a is on the outside of the 1/2 here, where the b is in the numerator, it's on top. So really, I got to do this part first, right? I'm taking 6 times b divided by 7. So I have 1/2 times a plus 6 times b divided by 7. So I'm just writing it out in a sentence, okay? And just make sure you write out your operations. And we're also going to go the opposite way, right? Now I'm going to get a little verbal expression, and I'm going to write an algebraic expression for it. So 5 less than a number. So basically I have, I'm also, whenever it says a number, just give it a variable. Give it a variable. I'm going to use n, because n for number, I guess. So 5 less than a number. Well, less than, I'm thinking subtraction, right? I'm thinking a minus sign. So now I got to think, is it 5 minus n, or is it n minus 5? Well, I'm taking 5 less than that number. Okay, so I'm taking the number and I'm taking 5 less than that. So let's say the number is 12. Well, 5 less than 12 is 7, isn't it? So think about this. Would my 12 go here, or would my 12 go there? If 5 less than 12 is 7. I would think this way, right? So whenever it's less than, they kind of get switched around, don't they? So my answer right here would be n minus 5. That would be my expression that I write for that, okay? It's not 5 minus n, because I'm saying 5 less than that number. 5 less than that number. Let's go to the next one. 9 plus the product of 2 and d. That's a little easier. So I got 9 plus the product, which means multiplication, right? The product of 2 and d. So I'm multiplying 2 times d. Well, when I write that a number and a variable being multiplied, I just write them right next to each other. So the product of 2 and d, 2 times d. I don't want to put my x in there for multiplication, just put them next to each other. And lastly, 2/5 of the area m. 2/5 of m. Well, if I think of, let's say I did half of 10. I'm going to take half of 10. Well, what's half of 10? 5, isn't it? So what am I doing? Am I taking 1/2 times 10, 1/2 divided by 10? What are we doing there? Well, if I think about it, it's actually multiplication, isn't it? If you do that on a calculator, 1/2 times 10, or 0.5 times 10, you end up with 5. So whenever I say of, using a fraction, that means multiply. So 2/5 of m, the area m. So 2/5 of m. So 2/5 times m would be my expression. Okay, just writing out the expression. And we could also get a story problem with this. And this is where writing the expressions helps, because when I get a story problem, by setting up an equation or expression, it helps me to solve. So Mr. Adams bought 2 adult tickets and 3 student tickets for the planetarium show. Write an algebraic expression that represents the cost of tickets. So first things first, I have to give variables for things that I don't know. Well, if I think about it, I bought 2 adult tickets, that's good to know, but I don't know how much they cost, do I? So I'm going to give the letter A for adult tickets, okay? The cost of adult tickets. So A is going to stand for cost of adults. The other thing I don't know is how much student tickets are. I know I bought 3 of them, but I don't know the cost of student tickets. So I'm going to give S for student tickets, the cost of student tickets. And I'm going to write an expression to find the total cost. Well, I bought 2 adult tickets, and I bought 3 student tickets. Well, if each adult ticket was like $4, that's going to be $8 total for adults, right? So 2 times A, the cost, right? So if it's $4, 2 times 4 would give us 8. Same thing with students, 3 times S. Right, because we don't know what the cost is of the students, so we give it S. And what are we doing when we have both costs? We're going to add them together to get the total cost. Okay, and I don't need to say equals anything because it just asks for an expression, so I'm done. Right, here's my expression. If I really wanted to, I could have wrote this as 2A plus 3S equals maybe C for total cost if you wanted to. Okay, but it doesn't matter. This is just fine. Right here, right in the expression. So basically you're just given a variable for unknowns and write yourself an expression. Okay, so that's all I got. A lot of this is a review to you, so go ahead and get to work.